In the last video, we were talking about packages and how they help to make your code more maintainable by breaking them into independent pieces containing logically connected functions that operate in one domain. Go language developers paid a lot of attention to initialization process by providing developers a tool for resources and variables initialization. Not every variable in your code is initialized with a zero value or just some predefined constant. It often happens that you have to initialize variables with more complex values. For example, you would like to have a mapping with integer keys from 0 to 100 for some purposes. The problem is that you cannot write any code except declarations outside functions, and on the other hand, writing everything in the main function or other function that you are going to call yourself can cause errors just because you forgot something. Here we have to mention that the first thing that is executed in a code module, not package, is variable declarations, and then the main function, and all that is called after. But Go offers special init functions that cut in this process and start to execute right after the declarations were processed. Moreover, you can have more than one init function in one Go source file. Let's practice some. Consider the next task. We have a map of integers to strings, and we would like to initialize this mapping to have keys from 0 to 9 mapped to empty strings at the start of the application. First of all, we declare the map of the needed type. Then we write the init function with an initialization code. And to check if everything works as expected, we print the map inside the main function. Let's run application. As you can see, the mapping is not empty, though the main function has only a printing call. So the init function worked for us. There's also another common practice in Go to use init functions, a registry pattern. The main purpose of this pattern is to get access to an object dynamically by requesting it from another object called registry by its name, rather than hard-coding object usage. Don't be afraid of the object term. We are going to discuss object in the next section, so get ready. A good example of this approach is the Golang database/SQL package. It has an exported registry and the exported function register that allows you to register your driver for a relational database. And the register function is called inside the init function. So, if you would like to change your database during your project's lifecycle, you would not need to care about rewriting your code. You would only have to find an appropriate driver and import its main package. After that, everything will work fine. Only if that package is written in a specific way, of course, but we will talk more about this in the next section. There we'll be discussing interfaces and advantages of object-oriented development. At this point, we finish our discussions on packages and their specifics. And we are going to discuss the last topic of current section, deferred code execution. So let's move to the next video.